today's video, we are going to learn about evaluation metrics. In the previous video, we have learned how to estimate the slope and the intercept. Using the estimates of slope and intercept, we have learned to build our regression line. And we have understood that regression is a process of establishing a relationship between independent variable and dependent variable. Always we are trying to predict something. Hence, whenever we make a prediction, we have to ensure that our predictions are accurate. Hence, to check if our predictions are accurate, we have a set of evaluation metrics. One such evaluation metrics we are going to learn in this video, that is train test split. Now, what exactly is this train test split? The train test split procedure is used to estimate the performance of machine learning algorithm when they are used to make predictions on data not used to train the model. So what are we doing over here? We are trying to estimate the performance of the machine learning algorithm when they are used to make predictions on data not used to train the model. This definition may look a bit difficult in the beginning, but I will explain it to you with an example. So let us take the example of sales of a product and TV expenditure which we had taken in the previous video. So over here we have our data set. We have the expenditure that we incurred on advertisements on television and the sales of a product. And we have seen that there is a positive relationship between the advertising expenditure and sales. That is, when your advertising expenditure starts rising, the sales also starts rising. So over here, what was the first thing that we have to do? Train test split. So the first thing we have to do over here is split the data into training and testing. So let's do it. So we will take 80% of our data for training. What is there happening in training is that you are training your model using the data on television expenditure and sales. We are training our model. And after training, we are getting a line. This line shows us the relationship between the expenditure on TV advertisement and sales. And this model is trained on the training set. Mostly, the train test split is taken as 80:20. You can take it according to your interest. Now, it is very important that the data that we are collecting should be large enough, because if our data is not large enough, we will not be able to split our data into train and test set. And if the data is not large, we will not have enough data points to train our model on. So such a model wouldn't be a good predicting model. And even for testing, it will have less amount of data which can be used for testing the model. So now over here we have taken 80% data for training and we have built our model using the training data. And the remaining 20%, over here, this remaining 20%, we will only take the value for the TV expenditure. We will not take the sales. We have built a model now. We are going to plug in these values into the model and then we will get the predicted values. Now our task is to check whether the predicted values and the actual values that you see over here, they are one and the same or not. It is very rare that both the values would coincide with each other, but mostly they would be very close to each other. So in testing set, what happens? We take only the input, that is the expenditure on television advertisement, and we will not consider the sales because sales is our target variable. And we are going to test our model that we prepared using the training set and see if the sales that you see over here, that is the actual values and predicted values, are close enough or not. Basically, this is your train test split, and your accuracy will depend upon the difference between the actual value, that is the actual sales value that you see over here, and the predicted value, because this model that we have created using the training set will give us the predicted values, and our motto is to find the difference between the two. Now, we are going to have a high training set accuracy because we are giving the both input and output to our model. So it trains well on the data and it captures everything from the data. Hence, our training accuracy is amazing. But there is a problem. Our out of sample accuracy or your testing accuracy is going to be low because you are not giving it the output, you are only using the input of it. So there is a chance that training accuracy would be good, which is not a good indicator, because if training accuracy is high, it implies that there is something known as overfitting of the data. It is learning too much from the data, it is learning a lot from the noise in the data. And when out of sample accuracy is low, that is testing accuracy is low, it is failing to learn from the data. It is not actually capturing entire data. Hence, there would be a chance that we have high training accuracy and low out of sample accuracy. To deal with all these things, we are going to study further evaluation metrics which would help us deal with all these problems. Now, to summarize, train test split is fast and easy procedure to perform. It is highly cost efficient. It does not take much cost in it. It is simple to use and interpret. It was easy to understand, it was easy to use, and it is easy to interpret. And remember, you cannot use this train test split on small data set because you do not have enough data points to train your model on, and you do not have enough data points on which you can evaluate your model. Hence, it is an appropriate technique only when we have sufficiently large data set. I hope everyone is clear with the idea of train test split, why we are doing it, the advantages of train test split, and when we should perform train test split is clear for one and all. Thank you.